Hello friends, welcome back. Today in this video we will be working on a new sensor which is an analog to digital converter, and that is MCP3426. So for more info about this sensor, let's go to controleverything.com and here search for our sensor, that is MCP3426. Here it is. It is a 16-bit 2-channel analog to digital converter, and some of its more important features are mentioned here. You can also buy this sensor from here. Now today we will be interfacing this sensor with the Raspberry Pi and a Python code, and for that the requirement is of code. So click on Resource tab and here you will find the Python code sample for MCP3426. Click on it and you can download all the codes from here as a zip file. You can also download the same code from our GitHub repository, which is Control Everything community. Now we need some hardware for interfacing and working of the sensor, so let's move to that part. In hardware connections part, first thing we need is a Raspberry Pi, and these are the GPIO pins of a Raspberry Pi. Now this is an I2C Shield. The Shield is available on controleverything.com and you can purchase it from there. The reason behind using this is to make connections with other I2C devices easy. So gently place this over the GPIO pins and make a connection like this. Now to power up a Pi, we need a micro USB cable and gently insert this in the power jack of the Pi. To provide an internet connection to the Pi, we have two options. Firstly, we can use the Ethernet or LAN cable like this and insert it in the Ethernet jack of the Pi. The second option is a wireless nano USB adapter and insert this in the USB jack of the Pi. You can choose either of the options, the choice is yours. This is our sensor MCP3426 and this is a connecting cable. Connect the sensor with connecting cable like this, and while making connection, make sure the brown wire of the cable should be connected to the ground of the sensor. And the same rule applies to the I2C Shield. And with this, we are done with the hardware part. Now let's move on to the interfacing and working of the sensor. For the interfacing of the sensor, first of all, we have to log into github.com and here we have to search for the repository which is Control Everything community. Click on it and here search our sensor MCP3426. Here comes our sensor and here is the Python code. But first, let's go to the instructions. We have to download and install the SMS library on a Raspberry Pi, and steps to install this library are given on this link. Please go through this link, note down all the relevant steps and install this library very carefully. After that, this is the command for running our Python code. Now let's get back to the code. As you can see, there is our code with .py extension. Firstly, in the code we have imported SMS library and time library, and in the writing section of the code we have written 0x10 for continuous conversion mode, channel 1 and 12-bit of resolution. In the reading data, we have read 2 bytes of data, which is raw ADC MSB and raw ADC LSB through this command and through the register 0x00. Now we have converted the data to 12 bits according to the formula given in the datasheet of MCP3426. In the last part, we have output the data to screen with this command. And with this we are done with the interfacing of the sensor. Let's see how this sensor performs and let's see the working of this. For the working of the Python code, first of all copy the entire code. Open the terminal and here create a new file with MCP3426 name and .py extension. Here paste the code and then save it. Now run our code with the command given in the instructions. As you can see, the initial value is almost 0 because nothing is connected to the channel 1 of the sensor. But when I connect a battery cell of 1.5 volt, you can see the output is now 1327. On again running the code, output is almost constant. So this is how the Python code works. Now let's move to the application and features of this sensor. The sensor is a 16-bit analog to digital converter with differential inputs. It is a low noise and high accuracy 16-bit delta sigma analog to digital converter. It is the family member of MCP3426 series from the microchip technology. The device can output analog to digital conversion results at rate of 15, 60 or 240 samples per second depending on the user controllable configuration bit settings. The device have two conversion modes, one-shot conversion mode and continuous conversion mode. The application includes portable instrumentation and consumer goods, temperature sensing with RTD and thermocouple, bridge sensing for pressure, strain and force, weigh scales and battery fuel gauges, factory automation equipment and many more like this. This sensor can be purchased from our website, that is controleverything.com. You can download the code from resource tab and after that as a zip file. Also, you can have the code from our GitHub repository, which is Control Everything Community. In the end, I would like to clear, if you have any further queries regarding the interfacing and working of the sensor, you can reach us on controleverything.com and you can also post comments on our community page. For articles and blogs on various sensors like this, you can look us on instructable.com and you can subscribe our YouTube channel for more video tutorials like this. In the end, I hope you enjoyed the video and have a good day.